Bungee jumping is one of the most popular and accessible extreme sports in the world. However, there's a reason it is considered an extreme sport. There's a lot of room for danger, causing injuries or even death.
To safely complete a bungee jump, the jumper must be weighed to ensure they are using the right rope as to not snap the bungee, and the rope cannot stretch greater than the distance to the ground. Luckily, there are calculations which bungee professionals can use to make sure everyone has a fun time.
During the jumper will experience a few different forces. First is the force of gravity acting downward. This force is easily calculated as mass times gravity. This force will not change during the duration of jump since the person's mass won't change, nor will the Earth's gravity. To find the spring constant, we must divide the force of gravity by the change in length of the cord. When we multiply mass by gravity to find the force of gravity, it is important to use the mass of the bob or person and not the mass of the spring or bungee cord. We must also use the maximum length the cord can stretch and subtract the length of the cord when no force is being used to stretch it.
Second is the force of tension acting up through the bungee cord. This one is a little more complicated. The force of tension will not be felt at first, but when the cord starts being stretched, the force of tension will increase, slowing the person down until they eventually bounce back up. The spring constant is very important since people with different weights will be using cords with different spring constants.
Hooke's law states that the force of tension can be calculated as the spring constant multiplied by the change in length of the cord, or the instantaneous length minus the initial length. Naturally, this is why the force of tension will be greater the more the cord is stretched. The force of tension becomes greater and greater while the force of gravity remains constant. Eventually they reach an equilibrium and the mass stops falling.
We made a miniature model to simulate the forces involved in bungee jumping. We used a spring as a replacement to a bungee cord and hung a 0.8 kilogram mass from the spring. We let the mass go at the top of the jump, and as you can see in the video, the mass reaches the bottom of the jump where the force of tension is the greatest, and the restoring force pulls the mass back up towards the equilibrium point. At the top, the restoring force acts as a force of gravity, which pulls the mass back down below the equilibrium point, and this action repeats itself until the mass comes to a stop. In real life, people apply brakes to the bungee cord to slow the person down until it's safe to pull them back up.